Hey students, this is lesson 8.1, adding and subtracting polynomials. So we're going to learn how to do add and subtract polynomials. You might want to look this vocab over. Obviously there's a new word here, polynomials. You might want to know what that is. These are the answers we came up with in class for this. And I'll just number these and then we'll use those in the right place. Monomial, or a sum of monomials, is a polynomial. That's 3. A polygraph test measures whatever. A triangle is one example of a polygon. So the prefix poly actually means any number. So, and we're going to have some more specific definitions coming up here for different types of expressions. So we're going to learn how to classify, add, and subtract polynomials. Let's start with learning how to tell what the degree of a monomial is. And we have a little definition up here. The degree of a monomial is the sum of the exponents of its variables. So we have to add up the exponents. And the degree of a non-zero constant is 0. So anything that's just a number, that degree is 0. And that makes sense because, like, let's look at the number 5. We could also write that as 5x to the 0 is the same as 5 because any number to the 0 power is 1. So it's considered degree 0 when it's just a constant. All right, so let's check this out. And what you might want to do is write it using an exponent. So 8x is the same as 8 to the 0. Oh, that's wrong. 8 to the first times x to the first. But we're only concerned with the variables' powers. So we're only concerned with this 1. So this is the first degree monomial. So we'll just say degree 1. All right, this monomial, and the reason it's a monomial is because there's nothing added to it. It's just one term with only multiplication in it. So here we're just going to add up these powers. So this is 2 plus 7 is a 7th degree monomial. And then this last one, like we learned up here in the definition, the degree of any non-zero constant is 0. So this is a 0 degree monomial. All right. Go ahead, I'll let you do this, and you can check back with your answers. All right, here's your answers. Remember that the degree of any non-zero constant is 0. So we use that in this problem, and to know that we're not going to add anything because the expression has a coefficient other than 0. All right. What is the sum or difference? All right, when you're adding and subtracting monomials, and we've done this already, you're really looking for like terms. And if they have the exact same variable and the exact same power, you can combine them. And the reason you can combine them is because of the distributive property. I can write this as 2 plus 7 times x squared, the quantity 2 plus 7, because this x squared now distributes. It's multiplied by both of those and gives us 2x squared plus 7x, which I can simplify as 9x squared. So the idea here is that if they have the exact same variables and powers, you can combine them. They're like terms. So again, on this one, both of these terms are multiplied by x squared y. So using the distributive property, I can simplify it to 5x squared y. All right? So go ahead and try a couple of those. All right, how'd you do? Okay, we're going to name polynomials now. We can name them based on their degree or the number of monomials it contains. A monomial is, I'll just give a couple examples. A monomial is not a sum or difference. So just multiplication of numbers and exponents. 3x would be considered a monomial. Y squared would be considered a monomial. And any combination of variables and numbers where it's all multiplication. So I could do something like 4x squared y to the third z, and that would be a monomial. Okay? If it's a 0-degree monomial, then it's considered a constant. If it's a first-degree monomial, then it's considered linear. And the degree comes from the highest power used in the monomial when it's simplified. So the highest power here is 2, so that's considered a second-degree polynomial. And when that happens, we call it a quadratic. And those words are based on the kind of function you get when you have that. If it's a third-degree polynomial, then it's a cubic. If it's a fourth-degree polynomial, it really has no name anymore. We just call it a polynomial, fifth degree, sixth degree, anything beyond that. Now, if you simplify it and you get it down to one term, then it's considered a monomial. If you get it down to 2 terms, then it's a binomial. And here's examples. If you simplify it and it simplifies to 3 terms, it's a trinomial. Other than that, we could call any of these polynomials. So let's check this out. And it says write in standard form. Standard form means you're going to simplify, combine as many like terms as you can, and then write it in descending order of the degree of each of the terms. So the highest degree term here is x to the second, so we're going to write that first, 2x squared. And then this 6x is to the first power, so we're going to write that second. Okay? And now we look at the highest power, and that's the power of our polynomial. So it's a second degree polynomial. And a second degree polynomial, if you go back and look at the chart, we call that a quadratic polynomial. And you'll also notice there's 2 terms. Because there's 2 terms, we can name it according to the number of terms, and that's right here. That's a binomial. So we can say that this is a quadratic because of the second degree, and a binomial because there's 2 terms when it's simplified. So we can call it a quadratic binomial. All right, this third one, we need to simplify this a little bit here. We have negative 3x squared plus 1x squared, and that makes negative 2x squared. And then we're going to put it in descending order. So we're going to start with negative 4x to the third. Then we get negative 2x squared. And then we get plus 2. Now it's in descending order of power. We look at the highest power to see what degree it is. And it's a third, the third power. And so we can name this a cubic because of the third power. And then we count the terms, and there's 3 terms, so we're going to call this a cubic triangle. All right, use the chart, simplify the expressions, and put them in standard form and see if you can't classify it. I'll let you try that. All right, so we call 2x minus 3 plus 8x squared a quadratic binomial. All right, adding polynomials. So the revenue generated by a company and the cost of producing X units can be modified by polynomials below. One thing you should know, all the costs are negatives because you take away the cost to figure out your profit, so that's why that's a minus. But basically what we need to do is combine these two. We're just going to add them together because the costs are negative. And so we need to take 2x squared plus 120x. And one way we could do this is just line up the like terms. It'll make it a little bit easier. So we're going to put negative 0.5x squared there. And we're going to put negative 300x here. And if you want, you can write that as adding a negative 300. That's the same as subtracting. And then negative 8,000 we can put out here by itself because it doesn't really line up with anything. And now we can add these together. 2 plus negative 0.5 is 1.5. And 120 plus negative 300 is negative 180. Now you could write plus negative 180x or just minus 180x. And then plus negative 8,000. There's really 0 up here. And 0 plus negative 8,000 is negative 8,000. So, and then in simplest form, we're going to write this as subtracting. And that's what we get for a combined polynomial. All right? Go ahead, you try that. All right. Another way you can do this is by rewriting this subtraction as adding a negative and then distributing that negative there. And then we'll line up the like terms. So we really want to do this. 2x to the third plus 4x squared minus 3x. And everything in here now is going to become a negative when we distribute this negative. So this is going to become negative 6x to the third plus negative 5x squared plus positive. We're going to subtract the negative of that, so that would be a plus 4. Now we're going to combine like terms. And I'm going to suggest you do this a little different. When you look at the next problem, you'll see that they want you to line these up like addition, but I'm just going to underline the like terms and then combine them. And that's all I have for like terms. The blue underlined terms, 2 plus negative 6x to the third, that's my highest power. I'm going to do that first. You get negative 4x to the third. Now my red underlined like terms, we have 4 plus negative 5, that's negative 1. And I'm just going to write that as minus 1x squared. Okay, and the other two terms are not like terms, so I'm just going to put those with the rest of it there. And so that's my simplified polynomial. All right, I'm going to let you try that here. What I'm going to suggest is that you cross out all of that unless you think that's going to make it simpler for you. But what I would do is just write these all as addition. And this is adding negative. Distribute that negative and rewrite it. And I'll let you do the rest. Pause now, and then you can check back with your answer. All right, there's your simplified form of that. And just a quick lesson check here. Name the polynomial based on degree and number of terms. It's simplified, so we can say the polynomial has 3 terms. And the greatest degree of any term is 2. So the best name for this, something with 3 terms is a trinomial. Something with the greatest degree, that's 2, is quadratic. So we need quadratic trinomial. All right, that's it. I'll see you tomorrow.